Thank you so much for having us come out and talk to you about the research that we're doing, unlocking environmental issues from mud and waters in the Puget Sound. And this is a collaboration with myself and Dr. Cheryl Greengrove and these students here today. So one of the research projects that I work on is I look at harmful algal blooms in Puget Sound and actually throughout the whole entire world. The little dot there is an example of an organism called Alexandrium catanella. This dinoflagellate, this plankton that exists in the ocean, is about 30 microns. It's really small, and it exists in sediment. When it's in its dormant phase, it exists in the sediment, and then it can exist and come out into the water, act as a swimming organism, create saxitoxin. Shellfish can bioaccumulate that saxitoxin. Department of Health will put up these signs, and if you eat it, you might have tingling lips. You might have complete respiratory failures within an hour of consumption and die. So it's quite toxic. What we do, so it's really an important thing for us to study here in the Puget Sound. So on the left here, we have E.J. Rauschel, who's one of our graduates who's working at the Washington State Department of Natural Resources now. She's actually sampling some of the sediment in Commencement Bay. In the center, we have Allison Johnson, and she's a high school student at South Kitsap High School. And on the right, we have Jackie Busby, and she's actually looking at, she's working for the Washington State Department of Health, testing for these toxins. So right now I want to hand this over to Tracie, who's going to tell you about her research with respect to harmful algal blooms.
Thank you. Hi, everybody. My name is Tracie Barry. I've been working with Julie and Dr. Greengrove for about 2.5 years studying phytoplankton communities in Clayoquot Sound, British Columbia. Here we're actually doing some post-processing. So we collected water samples up there in 2016, 2017. And the university actually has a data set that goes back to 2010 in Clayoquot Sound. It's the only one. And so we had this incredible opportunity to look at post-blob, which was an anomalous warm water event in Clayoquot Sound, and the warm waters are retained in these fjords. So what happens when our water gets warmer? Well, we start to see a decrease in phytoplankton total abundance, primary productivity, which is actually what we saw, significant differences pre and post blob, as well as an increase in dinoflagellates and toxic species. So what does this mean? Well, we don't know yet. But we have a baseline for what's actually happening and what could happen in the future with increased warming waters, a model for climate change, and we get to actually see maybe the occurrence of new species, an increased prevalence of harmful species, and what kind of aquaculture effects we might see. With decreases in primary productivity, we also have decreases in shellfish production, as well as closures due to these toxic things like Alexandrium, Dinophysis, all these fun ones that kind of do unique things to your body. So we are looking forward to continuing our work in Clayoquot with future students.
So in 2008, I was asked by NOAA to figure out how much plastic's in the ocean. So it's kind of ridiculous, but if you look at this picture here, this picture really was a huge public outcry to really understand how plastics affects organisms within the ocean environments. And so actually what we were asked to do is to really look at creating methods here at the University of Washington, Tacoma. This is so cool. To create ways in which we can look at certain types of plastic, polyethylene, polypropylene, polyvinyl chloride, polystyrene. These are microplastics, anything that are as big as a width of a pencil to the width of a pin in specific locations in the ocean, along the beaches, within sediments on the beds or on the seafloor, and also within the water column and on the surface. And these 3 undergraduate students helped to develop methods that are used internationally to determine the amount of plastics that are in environmental samples. And so this is going to be, coming up, this is going to be Maggiejo and Abby Deaton, who are presently working here in the Puget Sound looking at plastics and sediments.
Hi, I'm Maggiejo. So I've been working with Julie for 2 quarters now at UWT. And as she said, my research is focused on analyzing and quantifying microplastics in Puget Sound bed sediments. So we get our samples from the Washington Department of Ecology, and they send those to us yearly, they monitor yearly. And I do most of the chemical processing and actually physically quantifying those microplastics in a lab setting. So, coming up here in a second. So these are kind of pictures of what we found so far. So on the left is what we would call fragments. So those are those like just little pieces of broken off plastic that you find. And then on the right is probably more typical of what I see in samples. So those are called fibers. And you can see like all the different bright colors. So that's what you would expect to see in pieces of plastic in sediments. So this is a time series from 2014 to 2018 showing the abundance of microplastics at each of these long-term stations. And I've done 2 years worth of data for 10 long-term stations, and we have some data from previous undergraduate researchers, and kind of came up with this map to show that, I mean, we found microplastics in every sample, except for one in a sample in 2017. The highest abundance we found was 27,000 microplastics per square meter, also in a 2017 sample. So the average for the last 5 years was almost 5,000 microplastics per square meter. And we can actually see a little bit that microplastic abundance is decreasing, but it's not actually statistically significant. So we definitely need just more data and continued monitoring of the Puget Sound sediments to figure out what's really going on over time.
So what we want to do is invite you guys to listen to our podcast called Searching for Microplastics and Pod Defiance. So here on UW Tacoma's our podcast, which is super excited. And so it's the research that Cheryl Greengrove and I are doing. And it actually features Tracie here. Maggiejo had it have class, but Abby Deaton is speaking on it also. So thank you so much for the opportunity to share our research with you.